Tektronix has been focusing on test equipment for mobile telecommunications for many years, and this year we introduced two new products at this show. The one product is a monitoring device for LTE networks. It is an LTE air interface monitoring probe. And the second product we are introducing is a 3G optimization solution. Many people ask, so what is really new for 3G? Why are you coming up with a 3G product? There's two things really which are new in 3G. Number one, it's the iPhone 3G, which was introduced 12 months ago. And there was Christmas of last year, where a lot of people have received a nice smartphone 3G. And our customers, operators around the world, have been reporting uptakes in data traffic in their mobile networks of up to 25%. So for the first time, really, in the existence of 3G, the ratio of data traffic, of mobile data in 3G networks is really taking off. And so this is why, for the first time, there is a real need for optimizing a 3G network. Because now you're moving from a, in essence, single service 3G network, where the only service which was transported in essence was voice, the few percentage points of data you can about forget, and now all of a sudden you have a true multi-service network with the requirement that you need to manage the different real-time requirements of the various services which are being transported over one and the same mobile infrastructure, and that's a big challenge. So 3G optimization is really hot, driven by the uptake in mobile data, and we're introducing a test solution which takes a very different approach than the more traditional drive test tools. We monitor at the connection between the base station and the radio network controller, which allows us to see all the calls, all the activity in a single cell, rather than just seeing a few test calls a drive test truck makes. Plus, and that's the really new thing for our optimization solution, through a patented algorithm, we can also identify the geographic position of the subscribers we are tracking. So in essence, what you can get is a map in real time in which we display all the critical statistics, key performance indicators as they are being called, in their location where they occur. So for example, you have a red spot on the area where you have more than 3% dropped calls, or you have a red spot at an area where your call setup time is more than 20 seconds. So this is a software upgrade to our existing solution. What you have to do, however, in order to be able to identify the geographic position of the subscribers, you have to have a complete coverage of that area, because the geographic positioning system works by using a algorithm which depends on measuring at all base stations which are around a specific subscriber. It's a triangulation mechanism, and so you need to have, if you have not yet, a complete seamless coverage of the area where you want to do that optimization. Then the geolocation, the positioning algorithms work, and then you get that information I just described. What we always reuse is the map material. We use Map Info or Google Maps. So every carrier, they have geographic data and information, mapping information. That can always be used because we have an open interface to our system, but they of course have to deploy probes around the RNCs, which allows us to capture all the data, but then can be linked with the mapping information the carrier has. So there's really a heterogeneous picture, I believe. There's some carriers who are very aggressive. There's Telia Sonera, for example, in Scandinavia. They've announced a first pre-commercial trial for next year already. There's T-Mobile and Vodafone, for example. They are also very aggressively moving after this. Docomo and Verizon are also very aggressive. And then there are other parts of the world. In China, for example, where we just have a 3G license out. So not all parts of the world are going to go equal speed, but I see a lot of push behind LTE. Obviously, for the next 2 years it will be HSPA plus, but remember, HSPA plus is really part of the evolution towards LT. HSPA plus is really introducing MIMO and beamforming as the next generation antenna technology, and this is what you have to have as a prerequisite for LT, for example. Obviously, LT has a different baseband processing and a different air interface, but there's a lot of things which are in HSPA plus, like the all-IP backbone, the all-IP infrastructure, which prepares the mobile network for LT. So it's really a seamless evolution as I see it for the largest part of the world. What we introduce is a monitoring probe for LTE, and this monitoring probe, other than the other probes we have in our program, is an air interface monitoring probe. Reason for that is that in LTE the intelligence is really moving towards the edge. You don't have a radio network controller anymore. Everything is in the LT base station, and with that you also lose this important measurement interface, the IUB. So the only way to get access to information like what the scheduler does, how retransmissions occur, or what quality of service is to measure at the interface. Now, this is very expensive, and we would much rather have had an interface like on the 3G side, like the IUB, but LTE just doesn't provide that. So we had to come up with a radio-based monitoring solution, which at the moment is the only way to find out how LTE is performing.